A note to the viewers before we start. This session is dedicated to those who aspire to score high marks in the examination. I have discussed some harder problems here. This doesn't mean that only these problems will appear in the examination. I have chosen these questions carefully so that you will be exposed to new techniques of problem solving, and I hope these techniques will help you in cracking newer problems which may appear in the examination. Let's get going. First question, show that sin theta over 1 plus cos theta plus 1 plus cos theta over sin theta equals 2 cosec theta. Let us start from left hand side. Sin theta over 1 plus cos theta plus 1 plus cos theta over sin theta. We need to add them up. Common denominator here is 1 plus cos theta into sin theta. Therefore, we multiply the numerator and the denominator of the first term by sin theta and the numerator and the denominator of the second term by 1 plus cos theta. We get sin square theta plus 1 plus cos theta whole square whole divided by sin theta into 1 plus cos theta. In the numerator, 1 plus cos theta whole square can be expanded using this identity. A plus b whole square equals a square plus b square plus 2ab. Here, a is 1, b is cos theta. 1 plus cos theta whole square will be equal to 1 square plus cos square theta plus 2 into 1 into cos theta, which is equal to 1 plus cos square theta plus 2 cos theta. Therefore, the numerator becomes sin square theta plus expansion of 1 plus cos theta whole square is 1 plus cos square theta plus 2 cos theta whole divided by sin theta into 1 plus cos theta. Let us regroup the terms in the numerator as sin square theta plus cos square theta plus 1 plus 2 cos theta. We know this identity. Sin square theta plus cos square theta equals 1. Therefore, 1 plus 1 plus 2 cos theta divided by sin theta into 1 plus cos theta. 1 plus 1 is 2 plus 2 cos theta divided by sin theta into 1 plus cos theta. 2 is a common factor in the numerator. 2 into 1 plus cos theta whole divided by sin theta into 1 plus cos theta. 1 plus cos theta is a common factor. Let us strike them off. We get 2 by sin theta. This can be written as 2 into 1 over sin theta. 1 over sin theta is cosecant theta. 2 into cosecant theta equals 2 cosecant theta equals RHS, right hand side. Second question, 7 times a 2-digit number is equal to 4 times the number obtained by reversing the places of its digits. If the difference between the digits is 3, find the number. Let the tens digit be x and ones digit be y, units digit be y. Now, the first number is 10x plus y. Number obtained by reversing the places of digits, 10y plus x. According to the first condition given, 7 into 10x plus y equals 4 into 10y plus x. Let us simplify this further by opening the brackets. 70x plus 7y equals 40y plus 4x. Let us arrange all the terms on the left hand side with like terms together. 70x minus 4x plus 7y minus 40y equals 0. 70x minus 4x is 66x plus 7y minus 40y gives minus 33y. 33 is a common factor here. 33 ones are, 33 twos are, therefore we get 2x minus y equals 0. Let us name this as equation 1. Now, according to the second condition, the difference between the numbers is 3. How do we write this algebraically? Look at this. Here, 7 times a number equals 4 times another number. Therefore, the number we multiply with 4 must be greater than the number we multiply with 7. Therefore, for this condition to hold, 10y plus x is greater than 10x plus y. With digits being equal, a number becomes greater if the digit in the tens place is greater. Therefore, y is greater than x. Thus, we take the difference y minus x equals 3. Name this as equation 2. Here are two equations, 2x minus y equals 0, y minus x equals 3. We can solve this pair of linear equations by the method of elimination very easily. Adding equations 1 and 2, we get minus y plus y, they get cancelled. 2x minus x is x. 0 plus 3 is 3. Therefore, x equals 3. Substituting x equals 3 in any of the above equations, y minus x equals 3. I have taken the second equation. Y minus 3 equals 3, y equals 3 plus 3, y equals 6. Therefore, x equals 3, y equals 6. Thus, the number is 36. Here is a note. 7 into 36 equals 252. 4 into 63 equals 252. 6 minus 3 equals 3. Therefore, number 36 satisfies all the conditions. Minus 36 is another answer since it satisfies both the conditions. 7 into minus 36 equals minus 252. 4 into minus 63. 63 is got by reversing the places of digits. This is also equal to minus 252. The digits cannot be negative. Remember this. 6 minus 3 equals 3. But in the examination, it is enough if we take only the positive value. Third question. If sec theta, secant theta plus tan theta equals p, then find the value of cosecant theta. We shall start with the given statement. Sec theta plus tan theta equals p. Sec theta is 1 over cos theta plus tan theta is sin theta over cos theta equals p. Since the denominators are equal, we can write this as 1 plus sin theta whole divided by cos theta equals p. Bring cos theta to the right hand side. 1 plus sin theta equals p cos theta. Squaring both the sides, we get 1 plus sin theta whole squared equals p cos theta whole squared. A plus b whole squared is a squared plus b squared plus 2ab. 1 squared plus sin squared theta plus 2 into 1 into sin theta equals p squared cos squared theta. Cos squared theta is equal to 1 minus sin squared theta. Sin squared theta plus cos squared theta equals 1. This is an identity. Therefore, cos squared theta equals 1 minus sin squared theta. Now, 1 plus sin squared theta plus 2 sin theta, open the brackets, p squared minus p squared sin squared theta. Let us arrange all the terms on the left hand side like this: sin square theta plus p squared sin squared theta. These two terms are having sin square theta, then plus 2 sin theta, and then the constant terms plus 1 minus p square equals 0. Now, the first two terms are having sin square theta as a common factor. On factorizing this, we get 1 plus p squared into sin square theta plus 2 sin theta plus 1 minus p squared equals 0. This is a quadratic equation in variable sin theta. Let us solve this using formula. A is 1 plus p square, b is 2, c is 1 minus p square. Quadratic formula is given by x equals minus b plus or minus root of b square minus 4ac divided by 2a. Sin theta equals minus 2 plus or minus square root of 2 squared minus 4 into 1 plus p squared into 1 minus p squared divided by 2 into 1 plus p squared. Look at this term, 4 into 1 plus p squared into 1 minus p squared. Here we can multiply 1 plus p squared and 1 minus p squared using the identity a plus b into a minus b, which is equal to a squared minus b squared. Sin theta equals minus 2 plus or minus root of 4 minus 4 into 1 squared minus p squared the whole square, whole divided by 2 into 1 plus p squared. Sin theta equals minus 2 plus or minus root of 4 minus 4 into 1 squared is 1, p squared the whole square is p power 4 divided by 2 into 1 plus p squared. Sin theta equals minus 2 plus or minus root of 4 minus 4 plus 4p power 4, opening the brackets, whole divided by 2 into 1 plus p squared. Then 4 minus 4 get cancelled. We get sin theta equals minus 2 plus or minus root of 4p power 4 divided by 2 into 1 plus p square. Sin theta equals minus 2 plus or minus square root of 4p power 4 is 2p square divided by 2 into 1 plus p square. Here 2 is a common factor for the terms in the numerator. Sin theta equals 2 into minus 1 plus or minus p square whole divided by 2 into 1 plus p square. 2 and 2 they get cancelled. Sin theta equals minus 1 plus or minus p square divided by 1 plus p square. Here there are two values of sin theta. Sin theta equals minus 1 plus p square divided by 1 plus p square, or sin theta equals minus 1 minus p square divided by 1 plus p square. Sin theta equals minus 1 plus p square divided by 1 plus p square, or sin theta equals, bring minus 1 common factor outside, minus 1 into 1 plus p square divided by 1 plus p square. 1 plus p square, 1 plus p square, they get cancelled. Sin theta equals minus 1 plus p square divided by 1 plus p square, or sin theta equals minus 1. Now, cosec theta is the reciprocal of sin theta. Therefore, cosec theta equals 1 plus p square divided by minus 1 plus p square, or cosec theta equals 1 divided by minus 1. Therefore, cosec theta equals, I will write 1 plus p squared as p squared plus 1 minus 1 plus p squared as p squared minus 1, or cosec theta equals minus 1. Fourth question. The sum of areas of two squares is 640 meter square. that is square meters. If the difference between their perimeters is 64 meters, then find the sides of the squares. Let the sides of two squares be x meter and y meter. Their areas are x squared meter squared and y squared meter squared. Their perimeters are 4x meters and 4y meters. According to the second condition, their perimeters are given 4x minus 4y equals 64. 4 is a common factor. 4 into x minus y equals 64. X minus y equals 64 divided by 4. Or you can divide the entire equation by 4 in the equation 4x minus 4y equals 64. You will get the same result. 4 16s are, then 4 1s are. X minus y equals 16 or x equals 16 plus y. Take this as equation 1. According to the first condition, x squared plus y squared equals 640. In place of x, substitute 16 plus y. Now, expand 16 plus y whole squared using a plus b whole squared equals a squared plus b squared plus 2ab. 16 squared plus y squared plus 2 into 16 into y plus y squared equals 640. 256 plus y squared plus 32y plus y squared equals 640. 2y squared plus 32y plus 256 minus 640 equals 0. 2y squared plus 32y minus 384 equals 0. 2 is a common factor. 2 1s are, 2 16s are, 2 192s are. Y squared plus 16y minus 192 equals 0. We need to solve this quadratic equation. Plus 1 into 1 minus 192 is minus 192. Let us factorize 192 like this. 2 96s are, 2 48s are, 2 24s are, 2 12s are, 2 6s are, 2 3s are. Now, consider this. 2 into 2 into 2 is 8. The remaining factors 2 into 2 into 2 into 3, that is 24. 24 and 8, the difference is 16. Therefore, minus 8 and plus 24, these are the factors which are required. We split the middle term as minus 8y plus 24y to give y squared minus 8y plus 24y minus 192 equals 0. Group them, factorize them. Y into y minus 8 plus 24 into y minus 8 equals 0. Y minus 8 into y plus 24 equals 0. Y minus 8 equals 0. Y plus 24 equals 0. Y equals 0 plus 8 or y equals 0 minus 24. Y equals plus 8 or y equals minus 24. Since y represents the side, y equals minus 24 is meaningless. Therefore, we should reject this value. Y equals plus 8. X equals 16 plus y. From equation 1, x equals 16 plus 8, x equals 24. Therefore, measure of the side of the first square equals 24 meters. Measure of the side of second square equals 8 meters. Next question. If roots of the equation a squared plus b squared whole multiplied by x squared plus 2 into bc minus ad whole multiplied by x plus c squared plus d squared equals 0 are equal, then show that AC plus BD equals 0. On comparing the given equation with standard form ax squared plus bx plus c equals 0, we get a is a squared plus b squared, b is 2 into bc minus ad, c is c squared plus d squared. If the roots are equal, then the discriminant must be equal to 0. Therefore, b squared minus 4ac equals 0. That is 2 into bc minus ad whole squared minus 4 into a squared plus b squared into c squared plus d squared equals 0. 2 into 2 is 4. 4 into bc minus ad whole squared minus 4 into a squared plus b squared into c squared plus d squared. 4 is a common factor here. Let us cancel them out. What remains? bc minus ad whole squared minus a squared plus b squared whole multiplied by c squared plus d squared equals 0. Let us expand the first term using the identity a minus b whole squared, a squared minus plus b squared minus 2ab. Here a is bc, b is ad. bc into bc is b squared c squared plus ad whole squared is a squared d squared minus 2 into bc into ad, that is 2abcd minus, first let us multiply a squared plus b squared by c squared plus d squared, then multiplied by minus 1. We get here minus of a squared c squared plus a squared d squared plus b squared c squared plus b squared d squared equals 0. Open the brackets. B squared c squared plus a squared d squared minus 2abcd minus a squared c squared minus a squared d squared minus b squared c squared minus b squared d squared, that is equal to 0. Now plus b squared c squared minus b squared c squared, their sum is 0. They get cancelled. Plus a squared d squared minus a squared d squared, they also get cancelled. What remains? Minus 2abcd minus a squared c squared minus b squared d squared equals 0. Multiply the entire equation by minus 1. We get 2abcd plus a squared c squared plus b squared d squared equals 0. Rearranging the terms, we get a squared c squared plus b squared d squared plus 2abcd equals 0. ac whole squared plus bd whole squared plus 2 into ac into bd equals 0. This is in the form of a squared plus b squared plus 2ab equals a plus b whole squared. A here is ac, b here is bd. Therefore, we can factorize this as ac plus bd whole squared equals 0. ac plus bd equals square root of 0 is 0. This is the result we wanted to prove. Sixth question, find the ratio in which the point P to x, y coordinate here is x, divides the line joining the points a minus 2 2 and b 3 7 internally. Also find the value of x. Here x1 y1 coordinates of a minus 2 2, then coordinates of b x2 y2 3 7, coordinates of p 2x, xy equals 2x. Using x coordinate of the point P, let us find the ratio first. x1 equals minus 2, x2 equals 3, x equals 2. m1 is to m2 we need to find. x equals m1 x2 plus m2 x1 divided by m1 plus m2. 2 equals m1 into 3 plus m2 into minus 2 divided by m1 plus m2. Let us bring m1 plus m2 to the left hand side. 2 into m1 plus m2 equals 3 m1 minus 2 m2. Open the brackets. 2 m1 plus 2 m2 equals 3 m1 minus 2 m2. Bring the like terms together. 2 m2 plus 2 m2. This is equal to 3 m1 minus 2 m1. 4 m2 equals 1 m1. Bring m2 to the right hand side and 1 to the left hand side. 4 divided by 1 equals m1 divided by m2. Therefore, m1 is to m2 equals 4 is to 1. Now, y1 equals 2, y2 equals 7, m1 is to m2 equals 4 is to 1. We need to find y, that is equal to x. Y equals m1 y2 plus m2 y1 divided by m1 plus m2. In place of y, substitute x. Value of y is x here. 4 into 7 plus 1 into 2 divided by 4 plus 1. X equals 28 plus 2 divided by 5. X equals 30 divided by 5. 5 ones are 5 6 are, x equals 6. Seventh question. In the figure, ABCD is a square whose vertices lie on the circle. Find the area of the shaded region if the perimeter of the circle is 88 centimeters. Here is the figure. Area of the shaded region equals area of the circle minus area of the square. Let us find area of the circle first. Here, perimeter is given. To find area, we need radius. So, using perimeter, let us find the radius first. C equals 2 pi r. 88 equals 2 into 22 by 7 into r. 88 equals 2 into 22 into r divided by 7. Let us bring 2 into 22 and 7 to the left hand side. 88 into 7 divided by 2 into 22. 22 ones are, 22 fours are. 2 ones are, 2 twos are. R equals 14 centimeters. Let us find the area of the circle now. A equals pi r square. A equals 22 by 7 into 14 into 14. 7 twos are, 7 ones are. A equals 22 into 14 into 2, which gives us 616 centimeter square or square centimeters. Area of the circle is 616 square centimeters. Now, let us find area of the square. We know that each angle in a square is a right angle. Angle A, angle B, angle C, angle D, each is equal to 90 degrees. Furthermore, diagonals AC and BD bisect each other at right angles in O. These are all right angles. Consider angle D. Since it is a right angle, it is an angle in the semicircle. So, AC is a diameter. Similarly, BD is also a diameter. O is the center of the circle. OA equals OB equals OC equals OD equals, each is equal to 14 centimeters. Now, triangle AOB, triangle BOC, triangle COD, triangle DOA, all are congruent. Area of the square ABCD equals 4 times area of triangle COD. You can take any of the triangles. 4 into 1 over 2 into CO into DO. CO is the base, DO is the height, or DO into CO. You can take DO as the base, CO as the height. 2 2s are 2 1s are. 2 into 14 into 14 equals 392 centimeter square. Area of the shaded region equals area of the circle minus area of the square. 616 minus 392, which is equal to 224 centimeter square. 8th question. If sin theta plus cos theta equals square root 2, then evaluate tan theta plus cot theta. Tan theta plus cot theta equals sin theta over cos theta plus cos theta over sin theta. Here the common denominator is cos theta into sin theta. Therefore, multiply by sin theta here, both numerator and denominator. In the second expression, second term, multiply by cos theta, both numerator and the denominator. We get sin square theta plus cos square theta whole divided by sin theta cos theta. But sin square theta plus cos square theta equals 1. Tan theta plus cot theta equals 1 over sin theta cos theta. We need the value of sin theta cos theta here. How do we find it out? Like this. Sin theta plus cos theta equals root 2. It is given. Let us square both the sides. Then sin square theta plus cos square theta plus 2 sin theta cos theta equals 2. We have used the identity a plus b whole square here. Now sin square theta plus cos square theta is 1. 1 plus 2 sin theta cos theta equals 2. 2 sin theta cos theta equals 2 minus 1. 2 sin theta cos theta equals 1. Sin theta cos theta equals 1 over 2. We got the value of sin theta cos theta. Let us substitute this here. Equals 1 over half, which is equal to 1 into 2 by 1, which is equal to 2. Therefore, tan theta plus cot theta equals 2. 9th question. The pth, qth and rth terms of an AP are A, B and C respectively. Prove that A into Q minus R plus B into R minus P plus C into P minus Q equals 0. Let the first term be capital A. To avoid confusion, I am taking the first term as capital A and the common difference be D. We have the formula AN equals A plus N minus 1 into D. Therefore, AP equals A plus P minus 1 into D, which implies A equals AP is A. Small letter A equals A plus P minus 1 into D. Let us open the brackets. A equals A plus PD minus D. Then AQ equals A plus Q minus 1 into D. Let us proceed as before. P equals A plus Q minus 1 into D. B equals A plus QD minus D. AR equals A plus R minus 1 into D. C equals A plus R minus 1 into D. C equals A plus RD minus D. Now, we shall start from the left hand side. A into Q minus R plus B into R minus P plus C into P minus Q. Let us open the brackets. AQ minus AR plus BR minus BP plus CP minus CQ. Let us substitute the values of A, B and C like this. Then multiply them. AQ plus PQD minus QD minus AR minus PRD plus RD, AR plus QRD minus RD minus AP minus PQD plus PD plus AP plus RPD minus PD minus AQ minus QRD plus QD. AQ minus AQ get cancelled, plus PQD minus PQD minus QD plus QD minus AR plus AR minus PRD plus RPD plus RD minus RD plus QRD minus AP plus AP, then plus QRD minus QRD, then all the terms get cancelled here to give us 0. This is equal to RHS. 10th question. The sum of first 3 terms of an AP is 33. If the product of the first term and the third term exceeds the second term by 29, then find the AP. Let the first term be A and the common difference be D. Then the first 3 terms are A plus D and A plus 2D. According to the first condition, A plus first term, then A plus D second term, A plus 2D third term, their sum is 33. Let us simplify this. 3A plus 3D equals 33. 3 is a common factor. 3 ones are, 3 ones are, 3 11s are. A plus D equals 11. According to the second condition, A into A plus 2D, first term multiplied by the third term is equal to second term A plus D plus 29. Now consider this. A plus D equals 11. A equals 11 minus D. Also, A plus 2D equals A plus D plus D. A plus D is 11. Therefore, this would be equal to 11 plus D. A is 11 minus D. A plus 2D is 11 plus D equals 11 plus 29. A plus D is 11. Now, 11 squared minus D squared equals 40. 121 minus D squared equals 40. 121 minus 40 equals D squared. D squared equals 81. D is plus or minus root 81. D equals plus or minus 9. D is plus 9 or D is minus 9. If D is plus 9, A equals 11 minus D, that is A equals 11 minus 9, which is equal to 2. If D is minus 9, then A equals 11 minus D, A equals 11 minus of minus 9, which is equal to 11 plus 9 equals 20. So, there are 2 sets of values for A and D. A equals 2, D equals 9. Second set is A equals 20, D equals minus 9. For the first set of values, AP is, first term is 2, add 9 to it and go on adding 9 to it, you will get the succeeding terms 2, 11, 20, 29, 38, etc. For the second set of values, A is 20, D is minus 9. First term is 20, go on subtracting 9. 20, 11, 2, minus 7, minus 16, etc. Thus, we get 2 arithmetic progressions here. They are not one and the same. 11th question. The angle of elevation of the top of an unfinished building on a ground at a point which is 100 meters away from the base of the building is 45 degrees. How much height the building must be raised so that its angle of elevation from the same point is 60 degrees. Take root 3 equals 1.73. Let AB denote the unfinished building. Here is the building. Let C be the point 100 meters away from the base of the building. This is 100 meters. Now join CB. Angle ACB is 45 degrees. Let BD be the height. The building must be raised further. Join CD. Angle ACD is 60 degrees. Let AB equals H meters and BD equals X meters. Tan angle ACD equals AB over AC. Tan 45 equals H by 100. 1 equals H by 100. 1 into 100 equals H. H equals 100. Now, tan angle ACD equals AD divided by AC. Tan 60 degree equals H plus X divided by 100. Root 3 equals 100 plus X divided by 100. Bring 100 to the left hand side. Root 3 into 100 equals 100 plus X. 100 root 3 minus 100 equals X. X equals 100 is a common factor. 100 into root 3 minus 1. X equals 100 into value of root 3 is given 1.73 minus 1. X equals 100 into 0.73. X equals 73. Height that must be raised BD equals 73 meters. 12th question. A cone of radius 10 centimeters is cut into two parts by a plane through the midpoint of its vertical axis parallel to the base. Find the ratio of volumes of the smaller cone and frustum of the cone. Here is the figure. AB is the vertical axis and the height of the cone. O is the midpoint of AB. OD is parallel to BC. By converse of midpoint theorem, D is the midpoint of AC. By midpoint theorem, OD equals BC over 2 equals 10 by 2 equals 5 centimeters. Also, BO equals AO equals H centimeters. For the smaller cone, R equals 5 centimeters. For frustum of cone, R1 equals 10 centimeters, R2 equals 5 centimeters. Volume of smaller cone divided by volume of frustum of cone equals 1/3 into pi into r squared into h divided by 1/3 into pi into h into r1 squared plus r1 r2 plus r2 square. 1 by 3 and 1 by 3 get cancelled. Pi and pi get cancelled. H and h get cancelled. What remains? R squared divided by r1 squared plus r1 r2 plus r2 squared. Let us substitute the values. 5 squared divided by 10 squared plus 10 into 5 plus 5 squared. This is equal to 25 divided by 100 plus 50 plus 25. 25 divided by 175. 25 ones are 25 sevens are. This is equal to 1 by 7. Therefore, ratio of volumes equals 1:7. 13th question. The sum of first n terms of an arithmetic progression is 210 and sum of its first n minus 1 terms is 171. If the first term is 3, then write the arithmetic progression. Sum of first n terms is symbolically denoted as Sn equals 210. Sum of first n minus 1 terms, Sn minus 1 equals 171. Look here, Sn means A1 plus A2 plus A3 etc. so on, plus An minus 2 plus An minus 1 plus An up to An. Similarly, Sn minus 1 equals A1 plus A2 plus A3 plus so on plus An minus 2 plus An minus 1. Let us subtract Sn minus 1 from Sn like this. While subtracting, we need to change the signs like this. Now, plus A1 minus A1, they get cancelled. Plus A2 minus A2 get cancelled. A3 minus A3, they also get cancelled. Similarly, An minus 2, An minus 2, they also get cancelled. These also get cancelled. Only plus An remains. Therefore, An equals Sn minus 1. An equals 210 minus 171. An equals 39. Now, we know the first term, A is 3. Now, to write the arithmetic progression, we need D. To find out D, we need n, number of terms. Using this, Sn equals n by 2 into A plus An. Using this formula, let us find out n first. 210 equals n by 2 into 3 plus 39. 210 equals n by 2 into 42. 2 ones are 2 21s are. Then 210 equals n into 21. 210 divided by 21 equals n. 21 ones are 21 tens are. N equals 10. This implies A10 equals 39. An equals A plus n minus 1 into D. A10 equals 3 plus 10 minus 1 into D. 39 equals 3 plus 9D. 39 minus 3 equals 9D. 36 equals 9D. 36 divided by 9 equals D. 9 ones are 9 fours are. D equals 4. A equals 3. D equals 4. Now we can write down the arithmetic progression. First term is 3. Go on adding 4. 3, 7, 11, 15, 19 and so on. 14th question. A man drives his car with uniform speed from place A to the place B, which is 150 kilometers away. Again, he returns to the place A by increasing the speed of the car by 10 km per hour, thereby reaching 30 minutes earlier than the time taken in the forward journey. Find the total time taken by him in forward and return journey. Distance between A and B equals 150 kilometers. Let the speed for the forward journey be x km per hour. Time into speed equals distance. Therefore, time equals distance divided by speed. Time taken for the forward journey equals 150 divided by x hours. Speed for the return journey equals x plus 10 kilometers per hour. Time taken for the return journey equals 150 divided by x plus 10 hours. Time taken for the return journey is less than that of forward journey by 30 minutes. 30 minutes equals 30 divided by 60 hours. 31s are, 32s are. This is equal to 1 by 2 hours. Half an hour. Now, 150 divided by x plus 10 time taken for the return journey is less than 150 divided by x time taken for the forward journey. The difference is half an hour. Now, to write the equation, you can add half to the smaller quantity, or you can subtract half from the greater quantity. Now, I am adding half to the smaller quantity. 150 divided by x plus 10 plus half equals 150 divided by x. You can also write down the equation as 150 divided by x plus 10 equals 150 divided by x minus half. Now, 150 divided by x plus 10 plus half equals 150 divided by x. LCM of the denominators equals 2x into x plus 10. Let us multiply the entire equation by 2x into x plus 10 like this. X plus 10 get cancelled. 2 and 2 get cancelled. X and x, they also get cancelled. What remains? 300x plus x into x plus 10 equals 300 into x plus 10. Let us simplify this. 300x plus x squared plus 10x equals 300x plus 3000. 300x get cancelled. It is on both the sides. X squared plus 10x minus 3000 equals 0. Let us solve this quadratic equation by factorization method. 1 into minus 3000 equals minus 3000. Let us find two factors such that their difference is 10, plus 60 and minus 50. Their sum is plus 10. Therefore, let us split the middle term plus 10x as plus 60x minus 50x. Group the terms. X into x plus 60 minus 50 into x plus 60 equals 0. X plus 60 into x minus 50 equals 0. X plus 60 equals 0, or x minus 50 equals 0. X equals 0 minus 60, or x equals 0 plus 50. X equals minus 60 or x equals plus 50. Since x indicates the speed, let us reject x equals minus 60. Therefore, x equals 50. Let us add the times taken for forward and return journey. 150 divided by x plus 150 divided by x plus 10 equals 150 over 50 plus 150 over 50 plus 10. 150 over 50 plus 150 over 60. 51s are 53s are. 32s are 35s are. This is equal to 3 plus 5 by 2. 3 plus 2 and a half. This is equal to 5 and a half. Total time taken in forward and return journey equals 5 and a half hours. 15th question. In an arithmetic progression, if mth term is n and nth term is m, prove that m plus nth term is 0. Let the first term be a and the common difference be d. Am equals n, an equals m. An equals a plus n minus 1 into d. We have got this formula. This implies m equals a plus n minus 1 into d. Let us open the brackets. M equals a plus nd minus d. Take this as equation 1. Similarly, am equals a plus m minus 1 into d, but am equals n. N equals a plus m minus 1 into d. Let us open the brackets. N equals a plus md minus d. Take this as equation 2. Subtracting equation 2 from 1, we get m minus n equals, change the signs and plus a minus a get cancelled, minus d plus d get cancelled, nd minus md. M minus n equals d into n minus m. M minus n divided by n minus m equals d. Minus 1 into n minus m divided by n minus m equals d. N minus m gets cancelled with n minus m. D equals minus 1. Now, consider the first equation. M equals a plus nd minus d. This is from equation 1. Now, in place of d, substitute minus 1. M equals a plus n into minus 1 minus of minus 1. M equals a minus n plus 1, or bring minus n plus 1 to the left hand side. M plus n minus 1 equals a. Therefore, a equals m plus n minus 1. Now, let us find out a m plus n equals a plus m plus n minus 1 into d. Substitute m plus n minus 1 in place of a and minus 1 in place of d. M plus n minus 1 plus m plus n minus 1 into minus 1, m plus n minus 1 minus m minus n plus 1. M and minus m get cancelled, plus n minus n get cancelled, minus 1 plus 1 gets cancelled, equals 0. Therefore, a m plus n equals 0. 16th question. If 7 times the 7th term of an AP is equal to 11 times its 11th term, then find its 18th term. According to the condition given in the problem, 7 into a7 equals 11 into a11. An equals a plus n minus 1 into d. So, a7 equals a plus 60. A11 equals a plus 10d. 7 into a plus 60 equals 11 into a plus 10d. Let us open the brackets. 7a plus 42d equals 11a plus 110d. 42d minus 110d equals 11a minus 7a. Minus 68d equals 4a. Bring 4 to the left hand side. Minus 68d divided by 4 equals a. 4 ones are 4 17s are. Therefore, a equals minus 17d. A18 equals a plus 18 minus 1 into d, that is a plus 17d. In place of a, substitute minus 17d. A18 equals minus 17d plus 17d. A18 equals 0. Therefore, 18th term is 0. In general, if in an AP, if m times the mth term is equal to n times the nth term, then m plus nth term is 0. Let us prove it. I am going to show the steps quickly. M into am equals n into an. M into a plus m minus 1 into d equals n into a plus n minus 1 into d. M into a plus md minus d equals n into a plus nd minus d. Ma plus m square d minus md equals na plus n square d minus nd. Ma minus na equals n square d minus nd minus m square d plus md. Ma minus na equals md minus nd minus m square d plus n square d. Ma minus na equals d into m minus n minus d into m squared minus n squared. A into m minus n equals d into m minus n minus d into a squared minus b squared is a plus b into a minus b, m plus n into m minus n. a into m minus n equals d into m minus n is a common factor there. Bring it out. D into m minus n into 1 minus of m plus n. D into a into m minus n equals d into m minus n into 1 minus m minus n. M minus n and m minus n. It is a common factor on both the sides. They get cancelled. A equals d into 1 minus m minus n. So a equals d minus md minus nd. Now a m plus n equals a plus m plus n minus 1 into d. A m plus n equals a plus md plus nd minus d. Substitute d minus md minus nd in place of a. Now d minus d minus md plus d minus nd plus nd, they all get cancelled to give us 0. 17th question. In an AP, if mth term is 1 by n and nth term is 1 by m, then prove that mnth term is 1. Let the first term be a and common difference be t. Am equals 1 over n and an equals 1 over m. An equals a plus n minus 1 into d. This implies 1 over m equals a plus n minus 1 into d. This implies 1 over m equals a plus nd minus d. Take this as equation 1. Similarly, am equals a plus m minus 1 into d. 1 over n equals a plus m minus 1 into d. 1 over n equals a plus md minus d. Take this as equation 2. Subtracting equation 2 from 1, 1 over m minus 1 over n equals, change the signs, plus a minus a get cancelled, minus d plus d get cancelled, nd minus md. Now, on the left hand side, make the denominators equal. Common denominator is mn, so multiply by n both numerator and denominator of the first term, here into m, then we get n minus m divided by mn equals d into n minus m. N minus m and n minus m, they get cancelled. This implies d equals 1 over mn. Now consider equation 1, 1 over m equals a plus nd minus d. From equation 1, 1 over m equals a plus n into 1 over mn minus d. I am substituting d equals 1 over mn only in the middle term. Look carefully, n cancels with n. This implies 1 over m equals a plus 1 over m minus d. We have 1 over m on both the sides. They get cancelled. We get 0 equals a minus d. 0 plus d equals a, that is d equals a. Therefore, d equals a equals 1 over mn. Value of a is also 1 over mn. Amn equals a plus mn minus 1 into d. Amn equals a plus mnd minus d. A is 1 over mn plus mn into d is also 1 over mn minus 1 over mn. Mn and mn get cancelled. 1 over mn minus 1 over mn, the sum is 0. Therefore, what remains? 1. Here we got the result. We proved the general result. Here is a specific example. In an AP, if third term is 1/5 and fifth term is 1/3, then find 15th term. Note that 15 is the product of 5 and 3. The 15th term will be equal to 1. Please give this problem a try. This is left as an exercise to you. In an arithmetic progression, this is 18th question. Sum of 11 terms is 44 and sum of next 11 terms is 55. Find the first term and the common difference. Let the first term be A and the common difference be D. Yes, 11 equals 44. Let us use the formula for Sn. Sum of first n terms equals n by 2 into 2a plus n minus 1 into d. Yes, 11 equals 11 by 2 into 2a plus 11 minus 1 into d. 44 equals, yes, 11 is 44, it is given. 11 by 2 into 2a plus 10d. 44 equals 11 by 2 into 2a and 10d have 2 as the common factor. Bring it out. 2 into a plus 5d. 2 ones are 2 ones are. They get cancelled. And again 11 ones are 11 fours are. 4 equals a plus 5d. Or by swapping the sides we get a plus 5d equals 4. Now, sum of first 11 terms is 44. That is, A1, A2, A3, etc. up to 11. Their sum is 44. Sum of next 11 terms is 55. That is, starting from A12 to A22, the sum is 55. So, sum of first 22 terms equals 44 plus 55 equals 99. Therefore, yes, 22 equals 99. Again, use the formula Sn equals n by 2 into 2a plus n minus 1 into d. Yes, 22 equals 22 by 2 into 2a plus 22 minus 1 into d. 2 11s are 2 1s are. Yes, 22 is 99. 99 equals 11 into 2a plus 21d. 11 ones are 11 nines are. Therefore, we get 9 equals 2a plus 21d. 2a plus 21d equals 9. Here are two equations, a pair of linear equations. We shall solve them using the method of substitution for a change. A plus 5d equals 4 can be written as a equals 4 minus 5d. Consider the second equation. 2a plus 21d equals 9. In place of a, put 4 minus 5d. 2 into 4 minus 5d plus 21d equals 9. Open the brackets. 8 minus 10d plus 21d equals 9. 8 plus 11d minus 10d plus 21d gives us plus 11d equals 9. Plus 11d equals 9 minus 8. 11d equals 9 minus 8 is 1. D equals 1 divided by 11. We have got the common difference. Now, to find the first term, let us take any of the equations. I am taking this equation. A plus 5d equals 4. Replace d with 1 by 11. A plus 5 by 11 equals 4. A equals 4 minus 5 by 11. A equals 44 minus 5 by 11. A equals 39 by 11. Therefore, first term A is 39 by 11. Common difference D equals 1 by 11. 19th question. A, B and P are the non-collinear points on a plane. the distance between the point A and P is 2 meters more than the distance between the points B and P. The distance between points A and B is 10 meters and AB is the longest side of triangle ABP. Is ABP a right angled triangle or not? Justify your answer using the discriminant of quadratic equation and also find the measure of AP and BP. Let us draw a rough diagram. Here are three non-collinear points. Join them AB, BP and AP. Let BP equals x meters. Then AP equals x plus 2 meters and AB is 10 meters. We know that sum of any two sides in a triangle is greater than the third side. Let us take BP plus AP greater than AB. X plus 2 is greater than 10. 2x plus 2 is greater than 10. 2x is greater than 10 minus 2. 2x is greater than 8. X is greater than 8 by 2. 2 ones are 2 fours are. X is greater than 4. Again, AB is the longest side. Out of x and x plus 2, x plus 2 is the longer side. This side, x plus 2, must be less than 10. That is, AP must be less than 10. X plus 2 is less than 10. X is less than 10 minus 2. X is less than 8. X is greater than 4 and x is less than 8. Combining the two results, we can write 4 less than x less than 8. This means that the value of x lies between 4 and 8 and x can have many such values. So, there are many triangles satisfying the given conditions. Do we have a right angled triangle among these? For a triangle to be a right angled one, the square on the longest side must be equal to the sum of squares on other two sides. Let us see what happens when we equate the square on the longest side to the sum of the squares on other two sides. AB squared equals AP squared plus BP squared. 10 squared equals x plus 2 whole squared plus x squared. Let us expand x plus 2 whole squared using the identity a plus b whole squared. 100 equals x squared plus 2 squared plus 2 into x into 2 plus x squared. 100 equals x squared plus 4 plus 4x plus x squared. 0 equals x squared plus x squared is 2x squared. Then plus 4x plus 4 minus 100. Bring 100 to the right hand side. 2x squared plus 4x minus 96 equals 0. Divide the entire equation by 2. X squared plus 2x minus 48 equals 0. Here we have a quadratic equation. Let us find the discriminant of this equation. A equals 1, B equals 2, C equals minus 48. Discriminant equals B squared minus 4AC. 4 minus 4 into 1 into minus 48. 4 plus 192, that is equal to 196. Since 196 is greater than 0, the quadratic equation has real and distinct roots. So, it is possible that ABP is a right angled triangle. Let us solve the quadratic equation. We can use formula method. I am going to use the factorization method. X squared plus 2x minus 48 equals 0. I am not going to show the details. X plus 8 into x minus 6 equals 0. X plus 8 equals 0 or x minus 6 equals 0. X equals minus 8 or x equals plus 6. Since x denotes the length of the side, we should reject x equals minus 8. Therefore, x equals 6 and x plus 2 equals 6 plus 2 equals 8. BP is 6 meters, AP is 8 meters. 20th question. If a squared, b squared and c squared are in AP, then prove that a over b plus c, b over c plus a and c over a plus b are in AP. If a squared, b squared and c squared are in AP, then b squared minus a squared equals c squared minus b squared. This is the property of AP. Now, b plus a into b minus a equals c plus b into c minus b. I am using the identity a squared minus b squared equals a plus b into a minus b. Now, I will transform this equation as b minus a divided by c plus b equals c minus b divided by b plus a. Let b minus a over b plus c equals c minus b over a plus b equals k, where k is a constant. Let us name this result as 1. Now, consider b over c plus a minus a over b plus c, second term minus the first term. Let us make the denominators equal. The LCM of the denominators is c plus a into b plus c. Multiply the numerator and the denominator of the first term by b plus c, second term by c plus a. Then we get b into b plus c minus a into c plus a whole divided by b plus c into c plus a. This is equal to b squared plus bc minus ac minus a squared divided by b plus c into c plus a. That is, let us rearrange the terms in the numerator. B squared minus a squared plus bc minus ac divided by b plus c into c plus a. Now, b squared minus a squared can be factorized as b plus a into b minus a. bc minus ac, c is a common factor, plus c into b minus a divided by b plus c into c plus a. Now, b minus a is common. Bring it outside. B minus a into b plus a plus c divided by b plus c into c plus a. We can rewrite this as b minus a over c plus b into a plus b plus c divided by a plus c. Look at the result 1. B minus a over c plus b equals k. Therefore, k into a plus b plus c divided by a plus c from equation 1. Therefore, second term minus first term, b over c plus a minus a over b plus c equals k into a plus b plus c over a plus c. Take this as equation 2. Again, we have got these two results. Let us have them close at hand. Similarly, third term minus second term, c over a plus b minus b over c plus a equals, by taking common denominator, we get c into c plus a minus b into a plus b divided by a plus b into c plus a. I am not going in detail here. C squared plus ca minus ab minus b squared over a plus b into a c plus a. C squared minus b squared plus ca minus ab over a plus b into c plus a. C plus b into c minus b plus a into c minus b by a plus b into c plus a. C minus b is the common factor into c plus b plus a whole divided by a plus b into c plus a. C minus b over a plus b into a plus b plus c over c plus a, that is equal to k into a plus b plus c over c plus a from equation 1. So, c over a plus b minus b over c plus a equals k into a plus b plus c over c plus a. Take this as equation 3. Look at equation 2 and 3. We can infer that b over c plus a minus a over b plus c equals c over a plus b minus b over c plus a. Second term minus first term equals third term minus second term. This is from equations 2 and 3. So, a divided by b plus c, b divided by c plus a and c over a plus b are in AP. Hope the video was of help to you. I will come up with new topic in the next session. Till then, bye.